Hi and welcome to this video where I will take you through the exciting world of phytic acid. I will tell you the difference between phytic acid and phytate in a short while. I will start this video by shortly showing you the composition of a grain and the different components and where we find this phytic acid. Then I will tell you what phytic acid really is and what the dangers can be when ingesting too much. I will show you this by giving you a specific example, which should make it a little easier to understand what damage it can do. When I have taken you through the concrete example, I give you some overall pointers and tell you a little about what can break down phytic acid, like the enzyme phytase and where you find specific high amounts of phytic acid. Lastly, I will show you a bunch of different things you can do to reduce the amount of phytic acid and also increase the chance of breaking it down. So let's first explore the insides of a grain. It looks like this. So first we have the bran. And the bran is the harder outer layer which is rich on dietary fiber, essential fatty acids, starch, protein, vitamins like B vitamins and dietary trace minerals. The bran is removed when producing white refined flour, so that you actually only have the endosperm, which is nice and white. That way the flour is more appealing to the customer, but it has lost a lot of what is nutritious about grains. The bran is also the source of phytic acid and contains phytonutrients which protect the grain from threats like germs and fungi and bugs. Then we have the algerone layer. It is the outermost position of the endosperm, but the composition is very different than the starchy part of the endosperm. It is in this part of the grain where the enzyme amylase is being synthesized during germination and sprouting that breaks down the starch into, for example, the simple sugar glucose that your body can use for quick energy. And as enzyme activity is increased, it again helps the digestion of carbohydrates. Then we have the endosperm. This is the middle layer of the grain that contains mostly carbohydrates and some protein and oils. It is the nutrition for the grain and surrounds the germ. In normal, refined white flour, this is all you get. The germ and bran are removed. So if you want the benefits of the entire grain, then buy whole grain flours or products. Some companies add back some of the nutrition after they mill the grains, but this does not make it a whole grain again, as this is artificial. Now we have the germ. This is the reproductive part of the grain that germinates when grown into a plant and is the sprouting section of the seed. It is a form of embryo of the seed. It is rich in polyunsaturated fats, so it is removed in refined flours to improve storage quality. Now to the phytic acid or phytate. This is a storage form of phosphorus in all plants needed to support germination and growth. So it's just not something in the grain to supposedly annoy us, but an energy source and something to help the plant. When it is bound to a mineral in the seed, it is called phytate and is in its salt form. You might have heard it mentioned either way, phytic acid, phytate, but I will call it phytic acid from now on. So phytic acid is an antinutrient, and you maybe have heard of that. An antinutrient is something that interferes with the absorption of other minerals and vitamins and nutrients, and is therefore something that you need to think about when eating whole grain. It needs the enzyme phytase to be broken down. What phytase does is neutralize the phytic acid and liberates the phosphorus. The phosphorus regulates protein synthesis and is therefore important in the development of new tissue and energy transformation in the sprouting seed. So what is the problem with phytic acid for humans and some animals? Well, the problem is that it can bind minerals in our body before they are absorbed. When it is in the intestines, it can bind, for example, iron or zinc and manganese, which your body then can't absorb and is excreted in waste. That's why it's called an antinutrient, because it makes other nutrients become a waste product, and we don't want that because we need our minerals. There are different reasons why phytic acid can become a problem for you. It can either be because a grain contains a big amount of phytic acid, a small amount of phytase to break it down, or both. If something contains both a high amount of phytic acid and a low amount of phytase, then it's a bad combo. Before I tell you what you can do to lower the phytic acid levels and which precautions you can take, I want to show you what happens when phytic acid messes with the iron in the body, and why it is important to think of these things if you ingest much phytic acid. Signs of iron deficiency include fatigue, decreased work and school performance, difficulty maintaining body temperature, and decreased immune functions. Now, iron is just one of the minerals that phytic acid can mess with, but I think it's the mineral that we know the most. Most of us know what it is in our blood, as we can taste it when we get a cut and immediately try to make it better by sucking on it. So I want to show you the chain reaction of what happens when phytic acid binds iron, not making it usable in the body. So here goes. So first of all, here is Mr. Phytic acid. He is being happy, knowing that he has a lot of important assignments to do for his host, the grain. Miss Iron is also very happy because she also had tasks in her host, the human, which is so important that human can die without her help. Unfortunately, the two entities did not get along very well. And as Miss Iron sees Mr. Phytic acid, she becomes very sad. She knows that she will not be able to fulfill her task in the body and just ends up like human waste. Ew! Not the most pleasant way of ending your days, and what a waste! But why is the iron so important, and why does it make too much phytic acid a problem for us? Well, in our red blood cells we have some protein molecules called hemoglobin that carries oxygen from the lungs to the body's tissues and returns carbon dioxide from the tissues back to the lungs. Really smart. In each of the 4 chains in the hemoglobin is a compound called a hem group, and in this little group is an iron atom, little Miss Iron. This iron atom is super important for transporting oxygen and carbon dioxide in our blood, so we need the iron very much. I will concentrate on the importance of the oxygen transportation in regard to the use of iron in the human body. So, here is a red blood cell on its way to the tissue with oxygen. In the tissue it meets a very cool dude called a mitochondrion, which is a very clever structure which main function is to generate energy in form of a molecule called ATP. I bet you have always thought that sugar was energy, but it is just an ingredient in the energy producing process in the body. Another part of the energy producing process is oxygen. So we want Miss Iron to be a part of a hem group with oxygen and being transported to mitomic, so that energy can be produced. We need energy for everything in the body, from fighting illnesses to thinking, to digesting, growing and exercising. Every bit of action needs energy, so we really need our iron in the body so it can be a valuable part of the red blood cell, carrying the oxygen to the powerhouse in the body, which makes energy for us and not ending up as a waste product. So this was to show you why we do not want too much phytic acid not broken down in our body, as it can mess with some essential processes. Phytic acid is present in beans and seeds and nuts and grains, all important in human nutrition, and very small amounts in some vegetable and fruit. If you are a vegetarian, like Veggie Susie here, you get a lot of beans and seeds and nuts and grains. So for some vegetarians, too much phytic acid can actually be a problem and lead to iron deficiency. Especially if you eat whole grain. Maybe make your own flours where the phytic acid is present, as you use the whole grain. I make my own flour from different kinds of grains. I eat nuts and seeds and legume, so I have to think about it. If you eat like most people do and buy your flour in the supermarket where you only get the endosperm of the grain and get rotten moderate amount of seeds and beans and nuts, then you don't really get a problem and you don't have to worry about it. But it becomes more and more popular to opt for the healthier options, because when eating the entire grain, you get so much healthy components that you miss out on when choosing the refined flours. And nuts, beans and seeds are so good for you too. So choosing to stop eating those healthy foods because of being scared of phytic acid is not the right answer too. The amount of phytic acid strongly varies from product to product, and a lot of different conditions play a part in the amount of phytic acid. Phytic acid is much higher in foods grown using modern high phosphate fertilizers than those grown in natural compost. It is not just important to see how much phytic acid is in a product, but how much phytase is in it. So say hello to Professor Phytase. He is in one of his moods and would really like to get his hands on Mr. Phytic acid, as his job is to break down Mr. Phytic acid and liberate the phosphate trapped in him. Therefore, Mr. Phytic acid gets really sad when he sees Professor Phytase, because he realizes that he will not be able to mingle with Miss Iron anymore and will be punished and destroyed. Now, we wouldn't have a problem if a grain would just contain enough phytase to neutralize the phytic acid. The problem is that our bodies cannot produce phytase ourselves, as we can with some other enzymes. So we only get the benefit from what we ingest. So why can a cow eat buckets of grain without falling over dead from iron deficiency? Well, ruminants are so lucky that rumen microorganisms actually produce phytase in their bodies, so it is not a problem for them. Nature is clever that way. So there are things we can do to both reduce the amount of phytic acid and take care of the phytase already in the food. And there are things we can avoid doing to destroy the phytase in the products to begin with. It is an enzyme and can be easily destroyed, and we do that a lot without even knowing it. So wheat, rye and barley has considerable amounts of phytase, but dried corn and oats have little or no phytase activity. Corn, oats and brown rice also contain a lot of phytic acid. So it is a little tricky to make, for example, a homemade corn flour without great amounts of phytic acid. If you, like me, love your grains with the bran on and eat nuts and seeds and legume, here are some pointers which can help reduce the levels of phytic acid in your food. First of all, it is said that 37 to 66% of the dietary phytate is degraded during digestion in the stomach and small intestine, when the diet is rich on plant food phytases, remember, in raw food. So the potential negative consequences can vary a lot. Now, sprouting enhances phytase activity, as it is activated through germination and therefore decreases phytic acid. And this is also one of the reasons why I sprout my grains before grinding my own flour. It's absolutely not the only reason, but it is one of them. Now, soaking your beans and grains or flour is also a way of reducing phytic acid and has shown to be pretty effective. The acidic liquid helps to break the bonds phytic acid formed with minerals. What you do is put your grain in water at room temperature with an acidic medium like yogurt, buttermilk, kefir, lemon juice or apple cider vinegar. I prefer apple cider vinegar as I always have that in my kitchen, and it doesn't affect the taste the same way dairy products can. You cover your product with warm water and add about 1 tablespoon of acidic medium for every half a liter or 2 cups of water. Then you put the bowl in a warm place so it doesn't become too cold. Depending on the bean, grain or legume, it takes different amounts of time for the soaking, but about 12 to 24 hours. Then you just rinse, dry and make your own flour, if that is what you want. If you also want to sprout your grain, make sure to do this before you soak them. So in that case, you soak, for example, your corn in water for about 6 hours, sprout in a sprouting tray, soak in acidic liquid, dry in a dehydrator, and grind. Sounds like a lot, but the amount of hands-on work is minimal. To bring the phytate content really down, you can add freshly ground rye flour or a sourdough rye culture to rolled or cut oats, cornmeal, rice or other low phytase grains in the soaking liquid. Rye has the highest level of phytase in relation to phytates of any grain, so rye is the perfect grain to use as a sourdough starter or as a contributor to raising the phytase level during soaking. Then we have fermentation. And fermentation by lactic acid bacteria can also help to break down phytic acid as it activates native phytase enzymes, and at the same time some of the acids produced during fermentation might actually boost absorption of certain minerals. Grains are traditionally mixed with a starter culture like whey, kefir, yogurt or leftover fermentation medium from the previous batch. You can make a sourdough bread or, for instance, ferment your oats and make a more digestible oatmeal, which then have a yeastier flavor, and being that oat is very low in phytase, this is a very good way of reducing phytic acid in oat. Given that Central America countries eat a lot of corn and prepares their own corn products, you would think that they have a big problem with getting too much phytic acid, as dried corn contains a lot of phytic acid and very little phytase. But what they do is use a process called nixtamalization, because untreated ground flour cannot form a dough, and it gives the corn tortillas and tamales their pleasant sourly taste after making this flour called masa harina. The corn is soaked and cooked in an alkaline solution, usually limestone or wood ash and water. It's washed and then hulled. In corn, phytic acid is in the endosperm, so you wouldn't get rid of it by removing the hull. Masa harina is not the same as corn flour or cornmeal and cannot be used as neither. You can buy limestone and make your own masa harina if you want to. Probiotic lactobacilli and other species of the endogenous digestive microflora can actually produce phytase, so if you have a good intestinal flora, you may have an easier time with foods containing phytic acid. So maybe you should start your day with a nice bowl of skyr or Greek yogurt. So when you mill the grain and the hull of the grain is broken, the phytase content begins to decrease right away. So therefore, preferably grind your flour when you want to use it if possible, just before using it. So heat damages or destroys enzymes like phytase. So cooking or baking the grain or flour will make it not contain active enzymes. If you therefore are using a grain, nut, bean or seed, which you know contains a lot of phytic acid for cooking, then you want to choose methods which help reduce the phytic acid levels before cooking, as you will not get help from the phytase after cooking to break the phytic acid down. And at the same time, cooking is unfortunately not enough to reduce your phytic acid amount. As grinding also can make the flour very warm because of the friction in the grinder. If you are grinding something to use in raw food, try not to overuse your grinder so it becomes too warm. It would be a shame to have active phytase because you're not cooking it, but then damage it in the grinder. So these were a couple of good pointers you can use if you consume a lot of high phytic acid foods and or low on phytase. It also depends on how you treat the grain and seed and nut and legume. So I hope you are now a little wiser on the subject and hope that you have enjoyed the video. Take care and enjoy all your healthy grains, nuts, seeds and vegetables. Bye! Thank you for watching my video. I enjoyed making it, and if you like it, don't forget to click the like button. If you would like to see my other videos, don't forget to subscribe and turn on the notification button. I wish you a pleasant day filled with great relations and experiences.